So in today's video we will solve the vault challenge in the Ethernaut series. Let's dive right in. So it just says unlock the vault to pass the level. And we have a bool saying determining if the vault is locked or not. And this vault is just a contract. We have a password. This password is what we need to know to hack so we can unlock the vault. We have a constructor in which the password is given. Upon deployment on the contract, we set the lock to true to start off to initialize this variable. Then we have an unlock function which is public, anyone can call this if they know the password. If the password is correct, we will unlock this vault. So what do you need to know about this challenge and how can we solve this? Well, first of all, nothing on the blockchain, really any data you store, is private, especially if you save it like this. For example, you have a password that is 32 bytes. It's just standing there. And this private keyword, what it does, what purpose does it has? It actually has a purpose, doesn't have the purpose of hiding the data, but it has the purpose of programmatically being private for other contracts. So other contracts cannot read this. But what you can do is, if you know the storage layout of each contract, you can just read this because it's on the blockchain out there, and the blockchain is transparent. Everyone has access to all the data and can read this, and you can read this with ethers, with JavaScript, just interacting with the blockchain, accessing this contract. So there are a few ways, of course, you can do this. The most visual way, I guess, is this, using this alchemy composer. And this is a tool that allows you to make JSON RPC calls to the blockchain, like get the token, the block number, get logs, get storage add. So we'll just choose the Ethereum chain, choose Grelly, then choose get storage add, choose the address of our contract, which we can get if we go inspect. So go to console, you can delete this and say contract, not confirm, contract.address. You get the address of the deployed contract if you have an instance, and then you can go back to alchemy, paste this in. And another thing you need to understand is how each contract has its own storage, permanent storage, much like a hard disk or SSD in computers. And how this contract storage is laid out, so it's basically an array of 2 to the power of 256 places or slots minus 1. So it has a lot of slots, and in each of these you can store 32 bytes of data. And these are all indexed from starting from 0 all the way to, I don't know. So just knowing this, we can read this data. So we'll just provide the contract address, get storage add. This is the method we should call to read, to access the contract's storage, and we'll just provide the index. So we said each slot has 32 bytes. In the first slot we have this boolean, and in the second one we have this bytes 32. They are ordered in that order, and if this was less than 32 bytes, it could have fit into the first slot. It would be in the first slot, but it's in the second one because it's 32 bytes. So instead of 0, we'll type in 1 for the second slot. Click on send request. You can choose specific block number or the latest, and you'll get what is stored in that slot, which is the password in bytes. So that's one way to find out the password. And now all you have to do is inspect to solve the challenge at least. Go to console and say something like await contract dot unlock, and then provide the password in bytes in a string, and that will basically finish solve the challenge. And at any point you can, after the transaction is done, you can say contract dot locked to see if the contract is locked. For now it is. So that's one way to solve this using alchemy. Another way is to with ethers.js. So alchemy basically gives you a user interface for ethers.js and all these JSON RPC methods. But I have a project myself where I was explaining ethers. I have a ethers crash course, and what this does is it says provider.getStorageAt You provide the contract address, the storage slot, and we have the same thing again, where we can, if I go to the website, you can read the password. And by the way, this is a full project. I'll put the link to the repository down below. And another thing I'd like to share, if you go to view the transaction on blockchain, you can even see the state changes you made in a specific transaction and find out the password that way from etherscan. So that's third way you can find out the password. For example, if you go to state, you can see everything that changed. Like you can see the balance changed, also some other things. Instead of overview, you can just click state. I cannot look for the password now. Actually, here it is. This is the password we're looking for. So we stored 1 for the boolean in the first storage slot and in the second storage slot. So storage address probably means index. So in the first index we have this, in the second index we have this. And also, just for the record, you can actually store data that is confidential on the blockchain, but you have to do this with zero knowledge proof, or just encrypt the data and then put the hash or the encrypted data on the blockchain. I think so, but this is unacceptable.